Hello, IB Chemistry students. Today we are in the lab to do an analysis of a rock that is rich in iron. So your job today is to conduct an analysis where you will discover the percentage of iron in this rock. So we're going to use the strategy called redox titration. The iron can be oxidized by potassium permanganate, and then we will be able, through this titration, to determine its percentage. Very first thing is, you're going to do a lab report on this. You need to understand what kind of equipment and materials we are using. We are using Allen Myers for the titration. We are using a burette, a funnel to help us transfer the liquid. You will need a 10 milliliter volumetric pipette, a pipette pump. We will also need a volumetric flask, a 250 milliliter volumetric flask. This is how we're going to dissolve the ore. You will need distilled water, and you will need sulfuric acid. Here, a 3 molar solution of sulfuric acid. This sulfuric acid will guarantee you have an acidic solution for the titration. You will have to find in the internet the chemical reaction we're going to perform here today. And you will see when you find it that you need sulfuric acid to make sure the solution is acidic. Erasmo prepared a solution of potassium permanganate. You will need to know the exact concentration of the solution. Assume you have no uncertainty. This is the concentration of potassium permanganate you have. Okay? I guess we're ready to start. Our very first job is to weigh the metallic ore we have. This is the piece we are going to analyze. So this is rich in iron, and we will weigh this in our analytical balance. So we place here in the balance. And we weigh. Look at the mass and make sure you annotate the uncertainty of the scale. Okay, now guys, we will get this piece of ore and we will dissolve it using sulfuric acid, because I need to make sure all this iron is aqueous. Before I do this, well, working with acids is always something dangerous. So whenever you go to a lab, you need to be wearing a lab coat made of cotton, which doesn't catch on fire very easily. You should wear gloves and goggles. Never go to a lab without all the safety materials you need. Okay? So when we add sulfuric acid, you will see this will slowly react. So we dissolved that ore in sulfuric acid. We transferred it to a 250 milliliter volumetric flask. And then the solution is now in this flask. So all the iron that was in that piece of ore is in here now and has a certain concentration. Remember, we're talking about 250 milliliters of solution. We will analyze this solution here through the titration. Very first thing is to add the potassium permanganate in the burette. Potassium permanganate is purple, and look, the IB will expect you to know that potassium permanganate is purple. To avoid any accidents, I want to use a waste beaker here. Okay? Let's continue. So we transfer carefully the solution to the burette. Look, this is a very dark solution, which makes observing the volumes in the burette very challenging. So you're going to have to be very careful when you are reading the scale here. Now I will use my left hand to open the stopcock, and I need to put this in 0. So I will be very careful until I find the 0 here. And if you skip and go a little beyond than 0, we can use the dropper to complete. And it's easy to do this because the liquid is very opaque. I just did it. So what I'm going to do now is I'm going to use the dropper to add some drops and reach the exact 0. There. Perfect. See, all you have to do is to be very careful. I don't know if you noticed, but I kind of raised my feet in order to see it horizontally. Because when we do this, we don't have the parallax error of looking at an angle. We should be always looking like this. Okay? So this is our burette with potassium permanganate. In order to be sure of the color we want to see, we can have a color standard. I can have some distilled water in here and place 1 drop of the potassium permanganate. When you do this, we get the color. So let's understand. The iron is yellowish. Potassium permanganate is purple. As potassium oxidizes the iron, the oxidation will discolor the permanganate. The moment I reach the end point, then if I add 1 extra drop of potassium permanganate, I'll be in excess. And then we will see this color. This is when we have to stop the titration and annotate the volume. Let's do this. So first of all, we will add exactly 10 milliliters of the solution of iron sulfate. Now, it is an iron sulfate because the iron was dissolved in sulfuric acid. So we will pay attention. This is very vertical. The liquid will go up. We pass the mark. Now, look very vertically. There. Now, I release it in our first Erlenmeyer. We will do 3 trials. You will see my first one, then I will project on the screen the volume of the other 2 trials, okay? Guys, look, there's a little bit of liquid that remains in the pipette. You don't have to worry about this. When the pipette was calibrated, this amount of liquid was already counted for. So this is not an error to your measurement. Now we are ready to start performing the titration. Now I'll remove the waste beaker and I place our Erlenmeyer in here. This is how I usually do. I like to use my left hand to open the stopcock, and I use my right hand to stir the solution. So now we're going to stop. We're going to start adding the solution. I don't know if you noticed, I'm kind of going fast here because I know I'm far from the endpoints. As I start getting closer, and I forgot a little detail. I need to make sure the solution is acidic, otherwise the reaction doesn't happen. So, we need to add sulfuric acid 3 molar to the titrant. Now, we guarantee the solution is acidic enough to react with the permanganate. Okay? Now we can continue. We have to have patience. This does take some time, and we don't want to pass the endpoint. So if you're good analytical chemist, you have patience. You can be faster in your second and third trial, because then you would know around what volume your color would change. But because this is my first trial, I don't know that yet. So I'll guess I have to do it very slowly. Look, the moment the drop reaches the solution, the oxidation process takes place, and the purple color disappears because manganese 2 plus is being formed after the oxidation. Iron 2 plus is becoming iron 3 plus, and potassium permanganate is becoming manganese 2 plus. Okay? And the color disappears. We don't need a pH indicator here. This is not an acid-base titration. It is a redox titration. And we have a natural indicator in this solution. It is the potassium permanganate. The moment all the iron reacted, the potassium permanganate will no longer react, and the color purple will remain. Every now and then, we can wash with distilled water the walls. Remember, water doesn't add any moles to the iron, so that won't introduce any error in your titration. Now, guys, I don't know if you noticed, but the color is becoming a little more persistent. This means we may be reaching the endpoint. Now we have to go slower to make sure we don't miss it. Okay, let's continue. Control the speed using your left hand, and I use my right hand. We are very, very close. I guess we're just one drop away. The color has already changed a little bit, so I'm going to try to put one drop. One more. And this is it. This is our endpoint. See, you have a color. It's not exactly like this one because you have the iron, which is orange. So the orange plus the purple is giving this color. But this is clearly different from the color you started your titration with. Now, what you have to do is to read your volume, and then you annotate. You're going to do this for 2 more times, and then you will have 3 trials. You know the drill. after you have your 3 trials, you're going to calculate the average of your trials, and of course you have to calculate your uncertainty. Then you're ready to do all of your calculations. This is the lab. Now you're ready to work.